in spite of that. Mycotoxins are derived from fungi, and these can be very dangerous. The mold that grows on peanuts is a notorious source of aflatoxin and can also be found in a wide range of foodstuffs. But fortunately for us, even oil produced from moldy peanuts can be refined and made into finished oil with very low levels of aflatoxin. Zearalenone is a mycotoxin found in corn oil, but this is normally stripped out of the oil by deodorization, although it is possible for some residues to remain. The fatty acids that are incorporated into oils contain double bonds with one of two configurations. Vegetable oils normally contain only the cis configuration, but that can be changed into the trans configuration by heating or hydrogenation. A fatty acid containing a trans double bond has a higher melting point than the otherwise identical cis acid. For instance, oleic acid, which has 18 carbon atoms and one double bond, which is C18-1, in the cis configuration, has a melting point of 14 degrees Celsius, whereas eleidic acid, containing a trans double bond but otherwise exactly the same, has a melting point of 44 degrees Celsius. Trans acids with their higher melting points make high melting point fats, which have similar properties to saturated fats and are therefore thought to be damaging to the health. The amount of fatty acid in a triglyceride that turns into trans isomer depends on the fatty acid profile of the oil. Saturated oil cannot form trans at all because it has no double bonds. The ease with which an oil forms trans isomers rises with the proportion of polyunsaturated fatty acids present, and the more unsaturated an acid is, the more likely it is to form trans. And we can see in this picture that canola and soybean, which have high amounts of polyunsaturated, double unsaturated and triple unsaturated fatty acids, form about 1% trans in 20 minutes at 260 degrees Celsius, whereas palm oil at the other end of a scale, which has a relatively low level of polyunsaturated fatty acids, only forms 0.1% instead of 1%. The amount of trans isomers formed is approximately linear with time, but rises very steeply with temperature. But fortunately, this process is well understood, so we can use this knowledge to control the formation of trans very accurately. If you operate a deodorizer with a high temperature stripping column followed by cooling, it allows the fatty acid to be quickly and efficiently removed. Trans isomers form quickly in the stripping column, but are limited by the short residence time. The rest of the process then proceeds at a lower temperature at which little trans is produced. It's also to use this approach to control the formation of glycidyl esters, GE, and to limit the formation of excess acidity in corn oil. Now we come on to 3-MCPD esters and glycidyl esters. Now these are substances which are present in oil in very small quantities, but still may be damaging to the health. Now these are two quite different substances. They form in different ways, and it's just that they become well known at about the same time. The levels of 3-MCPD esters and glycidyl esters is generally higher in palm oil than in other oils. And at present, 3-MCPD and GE are mainly a problem for palm oil producers, but they're starting to become an issue for other oils as well. Now, there's going to be more said in this conference about 3-MCPDs and GE. Wim de Gret is going to be talking about this in this slot tomorrow morning. And there's also going to be a session about the analysis of various contaminants at, I think it's 10:40 today. Yes, 10:40 today. Correct me. Yeah, 10:40. Yeah. So yes, I'm only going to go into these fairly briefly. 3-MCPD stands for 3-monochloropropanediol, which you can think of as a glycerol molecule with one of the OH groups replaced with a chlorine atom. The chlorine can also be in the center position, which makes 2-MCPD. The hydroxyl or OH groups can esterify with free fatty acids to make 3-MCPD esters. Glycidyl esters form from diglycerides when oil is heated. The rate of formation rises rapidly above about 230 degrees Celsius. Most of the investigations into GE and 3-MCPDs have been done in the palm oil industry, where the level of these substances are highest. But the same principles apply to other oils. In this slide, the conditions that cause either 3-MCPDs or GEs to rise are shown by a red arrow, and the conditions that cause them to fall are shown by a green arrow. Deodorization has little effect on 3-MCPDs because they are formed well below the deodorization temperatures and are not very volatile, which is why they're depicted by a blue arrow sort of lying on its side. GEs start to form rapidly above about 230 degrees Celsius, which is a fairly low deodorization temperature, but under the right conditions, they can be removed more quickly than they form. Mineral oil. Now, there's been an increasing awareness of the possible presence of mineral oil in vegetable oil. Probably the most common mineral oil contaminant is in vegetable oil is hexane, coming from the solvent extraction process. It's removed by deodorization and can accumulate in the vacuum seal tank. Now, fires are rare, but as an extra safety measure, a fan can be added to the vacuum system to draw away hexane and dilute it with air to keep it below the lower explosive limit. This table is from an article describing a method of analyzing the mineral oil content of vegetable oil, but take a look at the amount of saturated hydrocarbon in the sample of sunflower oil at the top of the column. 2,540 parts per million, or 0.25%, which is an outrageous quantity and indicates a very serious level of contamination indeed. But the authors of the article don't draw attention to it and don't seem to realize what an extreme result it is. It's sometimes possible for lubricating oil to leak from gearboxes and other machinery into the product. Any vessel where this is likely to happen should be shielded so that any leaks are deflected away. Other sources of mineral oil contamination include harvesting machinery and handling during storage. Edible oil should obviously be shipped in tankers that have only been approved for edible use and kept for that purpose. But mistakes can happen, and it's likely in the future that the users of vegetable oil will become more vigilant in checking for it. One of the problems with mineral oil contamination, and this was discussed quite a lot at the conference I went to in Australia before the lockdown, is that there's a very large number of possible substances that can be present, which makes analysis difficult. And the maximum level of contamination being called for by some parties is lower than what can reasonably or accurately be determined. So in summary, we can say that we're surrounded by contaminants even here, and they can never be reduced to zero. But standards set either by government or industry are probably going to continue to push us to the limit. Thank you very much.
Excellent. Thank you so much, Alan, for your presentation. I've got one question that came in. I'm going to go and get to that question.
I don't.
Nice job. And how does that?
I don't see it in my own question.
Yeah, I got it in through email.
Oh, right.
So all these different sources, right? So, very good presentation. There's a long list of contaminants. It can be long, right? You also mentioned that some of these compounds may form during processing. So there has been claims that minimally refined and EVO may be more beneficial than conventional RBD oils. Are there any studies examining, comparing the concentration of some of the contaminants you mentioned in these oils?
Well, so if you look at the one of these slides that I'll put this slide up again. Of course, the problem you have with EVO, so extra virgin olive oil. Let's just bring that up to maximize that picture. Let me just hang on. Oh no, it's not giving it to me. Can you can you see that? Can you see a picture there?
I do not. I don't think you're sharing the screen yet.
I'm not sharing it. No, that's what's happened. Let me try again.
Okay.
Share screen. So yeah, and this here mentions this is an analysis of extra virgin olive oil (EVO), and that still contains some contaminants that is picked up from the environment. This is mineral oil contamination, and maybe it's been picked up by handling machinery, a milling machinery, something like that. So of course, the snag with extra virgin olive oil is that you can't do any refining to remove it. So if you found something in extra virgin olive oil, some smoke has blown over it from a forest fire and it's been contaminated with one of the poly-aromatic hydrocarbons or something like that, you can't do anything to extra virgin olive oil to remove it. So in theory, extra virgin olive oil, it's great stuff. I mean, I've got some myself. I use it. I have confidence in it. But if it does get contaminated, it all bets are off. You can't do. You then have to say, well, I'll make this refined oil in order to remove the contaminants. But of course, you don't get any. You get very low levels of things like trans and 3-MCPDs, which are processing contaminants, which are actually derived from the processing itself.
Okay, and then so like a follow-up to that, then, would you say minimally refined and extra virgin oils are safer than RBD oils?
Well, I think generally, oil like this one here, and this has been refined. It's there's no reason to think that's not a safe oil to use. So even though I said, well, look, it's got contaminants in, it's got this, it's got that, there's no reason to think that that's unsafe to use. But if you look at olive oil, there's perhaps other reasons why you might like to have that. It's got substances in it which you haven't removed by processing, so it's got a very good fatty acid profile. It's a nice thing to use for Mediterranean cooking. So it's got different attributes. I don't think you could say that this oil here, because it's been processed, it's somehow harmful to the health. All of the things that might be harmful to the health have been limited to an extent where they're not going to cause you any real problem. But still, I mean, olive oil is good stuff, and I wouldn't criticize it.
So we got another question that just came in. Where does the chlorine come from in 3-MCPD?
Well, this is a good question. I mean, people have looked at, does it come from the soil? They've tried to use fertilizers and pesticides that don't contain any chlorine. It's sometimes present in the processing, maybe even in steam or the water used in processing. We talk about very low levels of it. So any plant that's growing is going to draw a small amount of chlorine from the soil anyway, because there's a small amount of salt in the soil, and a certain level of chloride is a natural part of any living thing. But I mean, in processing, a major source is bleaching earth activated with hydrochloric acid. And if you want to avoid 3-MCPDs, that's definitely one of the things you should avoid. And you should also avoid any other kind of processing reagent that includes that substance.
Mm-hmm. Very good. I guess I can ask one more here. Are there any regulations that are strictly enforced by the governmental agencies requiring routine monitoring of these compounds in the oils directly marketed to the consumers at retail, grocery stores?
Well, there are various laws. I mean, quite recently there was a European directive put out about oils shouldn't contain more than a certain amount of benzoapyrene and PAH4s and 3-MCPDs. And so there are these regulations that say you mustn't have these things in your oil. Now, I don't know whether they actually mention a measuring regime. It's just they're not supposed to be there, but how you actually prove it is difficult, because some of these things are quite difficult to measure.
Right.
So to measure for everybody who's producing oil to measure polyaromatic hydrocarbons every day, and that's quite a difficult thing to ask. And so I think you'd have to find, if you somehow got caught out with it there, well, it's causing trouble. And I think the industry is still trying to adapt to this. It's something I've only just started to hear about so far as soft oils are concerned. So you always used to hear about polyaromatic hydrocarbons. It's only a problem for coconut oil. 3-MCPDs, it's only a problem for palm oil. But yeah, it's starting to sort of creep into other oils as well. And then you've also got the whole business with mineral oil contamination. Nobody's really worked out a proper method of doing it. Nobody's agreed what levels we're going to monitor. So it is quite a difficult area. And with pesticides, people usually rely on saying, well, we've treated the oil to a certain level, therefore we must have evaporated all the pesticides. So you're not relying on measuring it, because that's measure every sample would be tremendous. You're relying on, well, I measured it once or measured it twice, and as long as I treat the oil like this, that's going to be okay.
Well, I did see there was one more question that popped up in the question box, Alan. It says, do you do any in vivo experiments?
Well, not personally, no. And it's not really what we're, I'm been working in edible oil processing equipment, and I'm not involved with, feeding oil to rats or myself, or though you just saw me do it. That's not really an experiment. I seem to have survived the treatment, but no, I'm not involved personally with any kind of testing in animals or people of the various effects of these contaminants.
All right, so there's another question. Do you see the next one? Is there any evidence of growing concern of mineral oil in the US, or will this primarily be an EU issue?
Well, I think it sort of seems to be a growing concern in all places, I think. So even if it isn't, if there are places where it's not a growing concern, you'll start to notice it, I think. But it still seems to be, it was talked a lot at the conference in Sydney in February. It was a big topic of discussion. There were people there from all over the world, and there's still people. Well, we had trouble measuring, because mineral oil covers a vast number of possible substances. So there's all kinds of things that are classed as mineral oil, dozens and dozens of species classed as mineral oil. So very hard to, and there's also some natural components in oil that seem to mimic the properties of mineral oil when you analyze them. So it seems a very complicated subject, but it does seem to be moving up the awareness scale, shall we say.
I would agree. So I've got another question here. Could chlorine, going back to the chlorine topic, could chlorine come from bleaching in the process?
From what? Bleaching?
From bleaching.
Oh yes, yeah. I mean, as I said before, the if you're using bleaching earth that's been activated with hydrochloric acid, that has definitely a detrimental effect on 3-MCPDs, but it has a beneficial effect on glycidyl esters. So glycidyl esters can be destroyed by bleaching with acid activated bleaching earth, but 3-MCPDs certainly hydrochloric acid activated earth has a detrimental effect.
All right, doses in the toxin. How much of these contaminant intake will cause health problems?
Well, it's not. I mean, there are certain limits which are being set. So I think in the EU and I think other places have taken on similar limits. You know, benzoate is supposed to be at 2 parts per billion, and PaH4 is supposed to be no, sorry, benzoate is 2 parts per billion. PaH4 is 10 parts per billion. You know, pesticides. You know, I've seen figures of total pesticides below 10 parts per billion. You know, these are all very low levels, and there's no kind of, as far as I understand these things, I'm only I'm a chemical engineer, not really a biologist. These aren't kind of very drop dead. No, it's not right, but cliff edge limits. I mean, if someone said, okay, oil has to have 2 parts per billion of benzoate, and you get some oil that has 4 parts per billion, you could eat it, you're probably still going to be okay. So there's no like kind of cliff edge which these things suddenly become super dangerous. And I've seen lots of debates about with the GE and 3-MCPD about where are we going to put the limits and how many micrograms per kilogram of body weight should you eat and all of this kind of thing. So it's a very complicated subject, and there's books and books about it, and it's not really my speciality, I'm afraid.
Okay, I've got one more question. Can you tell us more about trans isomers and how they can be avoided?
Well, trans isomers, basically trans isomers are formed in the oil by time and temperature. So the longer you leave the oil in the deodorizer, is primarily a deodorizing issue. As long as longer you leave the oil in the deodorizer, the more transformed. That's more or less a linear process. So 20 minutes will make twice as much as 10 minutes. And then the temperature is kind of exponential, so that 240 and then 250 it'll be a lot more, and then 250 it'll be going up even steeper than that. So basically you have to sort of balance the try and find the right balance between the amount of time and temperature that deodorizes the oil and the amount of time and temperature that forms the trans. And unfortunately, these processes are fairly well understood, and you can make a kind of balance out that you say, okay, if I deodorize the oil at 245 degrees and I do it for half an hour, then I'll achieve all the effects I want to achieve, and I know that after that length of time the trans will in any particular type of oil will be such and such. So you can predict it quite well.
Good.
And I say also we mentioned this process of doing 2 temperature deodorizing. Can you see that?
Yes.
Yeah. Okay. So what's happening here is the oil is being heated in this top compartment to quite a high temperature, but only for a short period of time, so not too much transforms. Then the fatty acid being stripped in this pack column, and then after it comes out of the pack column being cooled down, so that the rest of the deodorization process takes place at a lower temperature where less trans can be formed. And you can go through all of this and you can calculate how much trans is going to be formed. You can calculate how much deodorizing you'll do in this section here, and it all comes out from that. It's a relatively well understood process.
Good. All right, there's probably one last question here. Is there any process for MOSH remotion? MOSH.
Oh, the mineral oil with mineral oil saturated hydrocarbons.
Yes.
Yeah, there we go. So what was the question again about?
Is there any process for MOSH remotion?
Removal, they mean
Removal,
removal.
probably, to remove, yes.
Well, yeah, not not entirely. I mean, the trouble is that I mean, some of them, of course, though, like hexane, are quite volatile. So you put them in a deodorizer, they all go away. But if you had something really kind of heavy, then it's questionable. The trouble is with this is that this is part of a difficulty with mineral oil, is that there's so many different types of substance that could be present. But if you got some really heavy sort of tarry substance dissolved in there, you obviously couldn't deodorize it away. It wouldn't be removed by normal bleaching. Maybe activated carbon would remove it, maybe it wouldn't. So I don't think it's a clear answer. There's not a clear answer to that at the moment. The answer is best answer is for it not to be there in the first place, although it can't be zero, because as you handle the seed, it's going to come into contact with lubricating oils and various other things along the way, and so to say that you could complete even this extra virgin olive oil here, has got some, because even though it's been it's there on the trees in Greece and Spain, and it's being handled very carefully, it is still impossible to avoid some of that stuff appearing on the seed.
Okay, we do have one more question.
Oh, they keep coming in.
Keep coming in, Alan. How about oxidized tags due to deodorization?
Oxidized
tags, TAGS. Triacyl glycerols, probably.
Oh, yeah, triacyl glycerol. Yeah. So, well, I'm not sure that's really, really a contaminant. I mean, well, obviously, when you're handling, or if you handle the oil without allowing any contact with oxygen, I think this is an important point. So, and then oxidization products in oil, are generally removed in bleaching. So the purpose of bleaching is to, you'll see in bleaching, you'll see the PV level, this is the peroxide value. This will go down. You should aim for the peroxide value to be zero, or as close to zero as possible at the end of bleaching. Anisodine value won't go to zero, but you should aim for it to be as low as possible. And then if you can then take the bleached oil and not allow it to see any air, keep it under vacuum or in a nitrogen blanketed tank, and then deodorize it, then you should avoid oxidized oil as best as possibly can.
All right, these keep on coming. There's one more question here. It's can trans esterification give rise to trans isomers?
Trans esterification? No, I mean, what happens with are we talking about interesterification here?
Trans esterification.
Oh, trans esterification mean, isn't that the process involved with biodiesel manufacture? So, but basically, no, I mean, esterification, when you're talking about trans or interesterification, you're moving one sort of fatty acid from one from one place to another. You're mixing up all the fatty acid, and that doesn't normally affect the nature of the fatty acids. What it does affect is 3-MCPDs and glycidyl esters. So interesterification will, let me get this right, it'll remove 3-MCPDs, but then creates a very large amount of glycidyl esters. And if you then bleach the oil, you can take both of them away. But it's not a useful process for, it's not a useful process for manipulating these things. So theoretically, yes, it has an effect, but it's not actually a useful way of controlling these things.
Okay, well, I think that concludes the questions that we've come in. We wanted to thank everyone for their participation and involvement in today's session. And of course, we want to thank you, Alan, so much for your very informative, interesting overview of oil contaminants. We appreciate your participation, and we hope that everyone continue to be with us. Thank you. Thank you so much, everyone.
Yeah,
and that concludes our live session.
There's still going to be a chat session on at 11:25. Is that right? 11.
That is correct. 11:25 Central Time. You can ask some more questions of Alan. He'll be available for another Q&A session. So we hope that you all can join us. And thank you so much, everyone, for being a part of our live session here. And thank you so much, Alan. Great job.